Okay, so today we're going to talk about how to solve a two-variable system using matrices. So I know that in Algebra 2 you solved two-variable systems, probably even in Algebra 1 as well, but you didn't use matrices, you used substitution, elimination, or graphing. So today's essential question is, how do I use matrices to solve a two-variable system? Use a little abbreviations there. So we have this two-variable system of equations, x plus y equal to 4, and negative 4x plus y equal to 9. And the formula is that you need the coefficient matrix times the variable matrix will give you, is equal to the constant matrix. And so our coefficients here, if we look at the coefficients, we have a 1 and a 1 in front of that first x and y. And we can kind of look at this and see that it sort of looks like a matrix. The system's set up pretty well. So if we create a matrix of 1, 1, negative 4, and 1, we've just taken all of the coefficients in front of each of our variables. We also want to make sure that our x's and our y's are lined up. That's really important. If you change that order, then you're going to not have your coefficients set up in the right way. So we have this column of x's and this column of y's. Now our variable matrix, yesterday I talked a little bit about when you're multiplying matrices and how crazy it is. We actually have a column matrix that has an x and a y that represents each of our two columns. Our first column was x's and our second column was y's. We now have a row for x's and a row for y's. And then our constant matrix is what our solutions were, so 4 and 9. And we have to make sure that those match up. That the first equation was a 4, the second one was a 9, and we put those in order. So that's how you turn a systems of equation into its own matrices. Now we want to solve for x and y, but we can't just divide matrices. Someone the other day asked me that. We're going to add, subtract, and multiply them. What about dividing? So since we don't divide them, we actually use the inverse operation, or we use the inverse matrix. I'm not going to ask you to sit here and find that inverse every single time. I know we did that yesterday. But instead, we're going to just type this in our calculator, use the inverse that we can find, and then solve for x and y. So there's really only 3 steps that you need to worry about for solving a two-variable system. The first one is that you're going to write the equation into matrices. The second one is that you're going to set up the coefficient matrix and the constant matrix in your calculator. So you're going to put this coefficient one and the constant one. So the two matrices that have numbers are going to go in your calculator. So put the coefficient, I'm going to abbreviate matrix, and we'll call that A. And the constant matrix, we'll call that B. B in your calculator. So I'm going to put this matrix in my calculator for matrix A, and this matrix in my calculator for matrix B. So this is a 2 by 2 that I'll need to put in, and a 2 by 1 that I'll need to put in. And then the last step here is that on your home screen, you'll need to type in, because you've put the matrix A, you'll need to type in A inverse, because we can't divide by this matrix to solve for x and y. We're going to use the inverse, and then we'll multiply by B, which is our constant matrix, to find our solution. So type in this to find x and y. So I'm sure an example would be necessary for you guys to understand what we're doing. So this first one here, we look at our systems of equations. We have our x's and our y's lined up for us already, which is excellent. And I'm going to create my matrix, my coefficient matrix 2, negative 5, 1, and negative 3. and then my constant, or my variable matrix, x and y, is equal to 12 and negative 3. Now that that's done, I'm going to type in my calculator. This will go in for A, this will go in for B, and then I can type in A inverse B. And when I solve that, I'm going to give you guys some time to type that in your calculators and solve that. For our first example, we're going to take a look at how we type this in. So if I want to type in my first matrix, I'm going to hit second matrix. It's the little x to the negative 1 button. And then I'm going to arrow over to edit. And I want to edit my first matrix. And so right now, depending on what model of calculator you have a 2x2. And I am going to type in that first constant matrix, coefficient matrix that we created, matrix A. So 2, negative 5, 1, and negative 3. And then I'm going to hit second quit, so I get out of that screen. Go back to second matrix. I need to edit my second matrix, which is my constant matrix, and that's going to be matrix B. It should be a 2x1. So edit the top there to make the right dimensions. And then I have 12 and negative 3. And so I now have the information I want in matrix A and matrix B. I go back to second matrix. I'm going to enter matrix A on my home screen. So I should have matrix A on my home screen. I do want to hit the inverse key. That's the same button that you press to get to matrix. You just don't hit second. So that's going to take the inverse of that matrix for us. We don't have to do that by hand. And then we're going to multiply that by matrix B. So we'll hit second matrix and just arrow down to the names, and we want to enter matrix B. So your home screen should look like this right now, A inverse B. And then you're going to want to hit enter. And your solution for what x and y are is 51 and 18. I know it's hard to read on here, but that's 18. So that's your solution to the first problem. Hopefully, you came up with 51, 18. So what that means is that if we look at our variable matrix, that is equal to x and y. So 51 is equal to x, and y is equal to 18. Now we're going to go ahead and do the second one, set that up. If we go ahead and set that up, we have our coefficient matrix will be negative 4, 2, 4, and negative 3. Our variable matrix is x, y, and that's equal to our constant matrix of 3, negative 6. So it's really important that you kind of show this setup, you show what you're doing. Then when we take the inverse of this, I'm going to label this A and this B, so I know that when I find A inverse of B, I'm solving for x and y. All right, I'm going to do this example a little more zoomed in so that hopefully you're familiar with the keystrokes now. I'm going to keep saying them as I'm typing them, but this way you can see what my screen looks like a little bit better. So for our second example here, I want to type in matrix A, so second matrix, arrow over to edit, and then I'm going to edit. I do have a 2x2 again, so I'm going to edit this so it's negative 4, 2, 4, negative 3. Those are my coefficients. And I'll hit second quit to get out of that screen, and back to second matrix to edit my matrix B. Matrix B this time is my constant matrix, which is 3, negative 6. Wow, totally just changed the dimensions there. 2 and 1 are what I need for my dimensions. And then matrix B is going to be 3 and negative 6. And so now I'm going to quit out of that screen, so second quit. I'm going to go back to matrix, hit enter when I have A, and now that's on my home screen. Hit the inverse key, which is the same button you hit to get to the matrix screen, and then second matrix B, just arrow down 1. And to solve this matrix, I get 0.753. I do want to write that answer as a fraction whenever possible, so I'm going to hit the math button, and then I see fraction, and I'll hit enter. And it'll change it to 3/4 over 3. And so in this case, I get 3/4 as my x value and 3 as my y value. So make sure you take some time to type this in your calculator. Make sure that you get the same answer that I did for x and for y. You might get 0.75. Remember that if you hit math fraction after your answer comes up, that'll change that to a fraction for you on your calculator. All right, let's take a look at C. So C, if we again take our coefficients, we have 2, -5, getting really bad at writing big enough matrices, 3 and -6. And then I have x and y as my variable matrices, and my constants are 15 and 36. And so I would type this in for A, this in for B, and I will type on my home screen A inverse B. I'll give you guys some time to solve that. Type that in your calculators. Third example, we're going to go back to second matrix. We're going to go over to edit. We're going to edit matrix A. It is a 2 by 2. We have 2, -5, 3, and -6. And we'll get out of that screen, second matrix, edit matrix B. And that is a 2 by 1. That the constants there are 15 and 36 from our problem C. And we'll get out of that screen, second matrix A inverse second matrix B. After you start doing a lot of these, you'll get a lot faster at this. So you should see that your solution is 30 and 9. So 30 for x and 9 for y. And so you should get that x is equal to 30 and y is equal to 9. You can also write this as an ordered pair as 30, 9. Either one of those answers is totally fine. Either one of those works for me. Okay, and we're going to move on to our last example right here. We have our coefficient matrix of 5, 3, 3, and 2. Our variable is x and y, and our solutions our constants are 4 and 0. So we're really just taking the information right out of the equations, making it matrix A and B. 4 and 0 came from our solutions, 5, 3, 3, and 2 came right out of the coefficients. Always make sure your x's line up in a column and your y's line up in a column. If you don't do that, if let's say these two were flipped, you would not get the right answer. It would be as if 2 was the coefficient on x and 3 was the coefficient on y. So you want to make sure that those are lined up in the right column for the right information. So when you solve this, we'll take A inverse of B in our calculators after we've input what A and what B are. So our fourth example here, as you type this in your calculator, you're going to hit second matrix, arrow over to edit that 2 by 2 matrix. You should have 5, 3, 3, 2. Second quit, second matrix, arrow over to edit and edit matrix B. When you edit matrix B, you should have 4 and 0. Second quit, second matrix, enter A, inverse, second matrix, enter B. So your solutions for letter D here are 8 and -12. And we'll get 8 and -12 for x and y. So you can write that as x is equal to 8, y is equal to -12. You can write that as an ordered pair, or you can write that as a column of your solution there. So if you flip your note sheet over, the first word problem that you're going to see talks about the perimeter of a deck. And so we need to write two word equations, two equations using variables. So we're going to write a system of equations here. One is going to be about the perimeter of the deck, because that's the first piece of information we have. So we have two variables. Let's assign those variables. Length is going to be L, so that'll just be length, and W will be width. And now we know what our two variables are going to be, we can write our two equations. So the perimeter of a rectangular wooden deck, if you want to draw this, please feel free to do so. we know that there's a length, and a width, and another width. So there's going to be 2 lengths and 2 widths when you're writing that equation. And I'm going to do lengths first. So 2 lengths plus 2 widths. And it tells us that that's going to be equal to 90 feet. The second equation for our system is that the length is 5 feet less than 4 times its width. So whenever I see the word less than, that tells me that that has to go at the end of the equation. So if I write an equation here, I have 5 feet less than, I'm going to be subtracting that. And 4 times the width is just 4 times W. And that says that the length is, so that means that L is equal to 5 feet less than 4 times the width. So that'll just be L. And now, this equation is not set up in the same format. We don't have standard form where we have our variables on one side and our number on the other. So we do have to change this equation. So I'm going to move my 4W to the same side as the L so that I have my variables on the left and my numbers on the right like I do in this first equation here. So when I do that, I get L minus 4W equals -5. And so if I want to write my coefficient matrix here, I have 2 and 2 across the top. And I have 1 as my coefficient in this one, and a -4 as my coefficient on my W. Now I have my variable matrix, which is going to be length and width. And I always like to write that cursive L, because I think otherwise my L's look like 1s, and then I get confused. And then I have 90 and -5 as my constant matrices. And so I'm going to type this in my calculator, where I have A and B, so I'll put this in for A and this in for B, and I'll want to type in A inverse B. All right, so for the first word problem that we did, we're going to hit second matrix, edit our 2 by 2 matrix, so that it is 2, 2, 1, -4. Get out of there, second quit, second matrix, edit matrix B, which has the 90 and the -5 that we just found. Get out of there, second quit. After you get really good at this and you've been doing the same problem over and over again, you can actually hit second entry. Entry is down here at the enter key. And since I keep typing in A inverse B, but I have new information in A and B, I can just keep hitting enter, so I don't have to go back and forth and do it. So this tells me that the length was 35 feet and the width was 10 feet for that rectangular wooden deck. When I solve that, I'll find out that the length is going to be 35, and the width will be 10 feet, I believe. Yeah, 10 feet. 10 feet. And so you can plug that in to double check to make sure. 35 times 2 is 70, and 2 times 10 is 20, and 70 plus 20 is 90. Or you can do 4 times 10, which is 40, minus 5 gives us 35. So if both of those work, and you can check your answer that way. All right, and so the last problem that we have today is about this bookstore buying some college textbooks. So it says Carly here purchased a math book and a novel that cost $54. So we're going to set math, M is going to be our variable for math book, math textbook. And we're going to use novel for our, N for our novel. All right, so now I'm going to write 2 equations that we're going to be able to solve using matrices. So if I buy the math textbook and the novel, it'll cost $54. That sounds super expensive for 2 books. And then the price of the math textbook is $8 more than 3 times the price of the novel. There's that more than idea. So more than, we're going to put that at the end of our equation, so that'll be plus 8. And so M is equal to 3 times the price of the novel, so 3N. Now again, this equation is not set up with our variables on one side and our numbers on the other, that constant term. So we need to change this. I'm going to move the 3N over again. So I have M plus 3N equals 8. So that is in a better format for us. If you want to write those over each other, sometimes I like to do that just to make sure I have that set up well. M over n, m plus 3n. Wow, I needed to subtract that. Back up for a second. So m minus 3n, I knew something was up with that. M minus 3n is equal to 8. So now we have our constant on the same side and our variables on the other. So my coefficient matrix is 1, 1, 1, negative 3. And my variables are m and n. And my my constants are 54 and 8. So now I have matrix A, and I have matrix B, and so I need to find A inverse of B. And for the last problem we have today with the math textbook and the novel, we'll edit our matrix, second matrix, arrow over to edit. And I'll edit that 2 by 2 matrix. This time I have 1, 1, 1, negative 3. Second quit out of that screen. Second matrix, edit matrix 2. I have 54 and 8 are what I should be putting in. Second quit, second matrix, enter A, inverse, second matrix, enter B. And I should get $42.50 for that math book and $11.50 for that novel. $42.50 for the math textbook. And the novel is $11.50. So there's my two solutions using inverse matrices. Didn't have to use substitution, didn't have to use elimination, just typed this in my calculator and it gave me the answer. So that's what you're going to be doing for today. You have some practice worksheets of some naked math and then a few problems so you can practice for your formative next week.